Dear students, welcome to this presentation of Unit 4, Weather and Climate. This presentation tries to mimic the explanation we will receive in a regular class, so please pay attention. Remember, this is a pre-recorded video, so you can pause it, you can rewatch it, you can go back, you can take notes, whatever you want. Listen carefully, and if you have any doubts, please write me to my email. First, we know that the main weather phenomena take place in the atmosphere. We know that the atmosphere is the layer of gases that surrounds. It's composed of several layers: the troposphere, stratosphere, mesosphere, thermosphere, exosphere, etc. And we live in the troposphere. For us, this one's the most important one, as most of our phenomena, the things that we are studying in this unit, will take place here, in the troposphere. But we also should know the stratosphere, as is the place where the ozone layer is located. You know that the ozone layer is this mass of gases, of ozone, of course, that can protect us from the ultraviolet rays. Here we can see the atmosphere surrounding the Earth with the several layers and how it causes the greenhouse effect. Remember, greenhouse effect is caused because of the radiation of the sun that enters, crosses the atmosphere, that it's transparent, so it doesn't stop the sun, and then it uh, increases the temperature of the Earth, of the surface of the Earth, and then acting as a greenhouse. Remember greenhouse where you keep the plants? Acting as a greenhouse, it contains the heat, the temperature of the sun, allowing the Earth to have a warm average temperature. Without the atmosphere, the temperatures during the day will be extremely hot and temperatures during the night will be extremely cold. Is the greenhouse effect caused by the atmosphere the one that allow us to have a regular temperature that allow us to live? Remember that the greenhouse effect is not negative for us. The negative is when the effect increases due to pollution. For example, these CFCs, these gases that can, well, increase the greenhouse effect, warming the air, caused by deforestation, combustion of engines. Another very important thing is the ozone layer that protects us from the radiation of the sun. Is a different effect than the greenhouse effect. The greenhouse effect maintains the temperature. The ozone layer protects us from the negative effect of the solar rays. And the ozone layer is due to the CFCs being eroded. The gases, the pollution, can destroy the ozone layer, creating what we call a hole, which is increasing and allowing more harmful rays from the sun to our planet. So, the atmosphere is made up of several gases: nitrogen, oxygen, carbon dioxide, ozone vapor, and so on. It has different layers that we have already mentioned, provides the required gases for us to live and to breathe. The living beings need gases to survive, and these gases are found in the atmosphere. It regulates temperature thanks to the greenhouse effect that we know, protect us from the sun rays and meteorites. It doesn't just stop the solar rays, it can also stop these pieces of rock that enter from the space. And finally, produce meteorological processes. What kind of meteorological processes? For example, the wind, which is the movement of gases, the rain, that is the water that falls from the atmosphere, from the clouds. The atmospheric pressure. Every meteorological process takes place in the atmosphere, so it's essential for us to. Then we can enter into our unit itself, which is weather and climate. Remember the difference between weather and climate. It's very important. Weather is the state of the atmosphere at some specific moment, while the climate is for a long period of time. For that reason, we can say that today there's a nice weather, sunny, it's not cloudy, it's warm, it doesn't rain, it has a good weather today, this specific day. But we can say, for example, that Spain has a warm climate. It's not a cold climate such as the ones we can find on the poles or in the north of Canada and so on. We can talk about the climate of a country because it's for a long period of time, for several years, while the weather is for some specific moment. Canada has a cold climate, but at some specific day it can be hot. In summer, for some peculiarities of the atmosphere, can be hot. It doesn't mean that it has a hot climate, but at some specific moment it's hot. That is the weather. And we can know that climatology is the science that studies climate. And of course, there's a science that studies weather, meteorology. The people that predicts the weather some specific day will have are called meteorologists, the ones that participate in weather forecasts in the TV. This is a meteorological map that represents the state of the atmosphere with the masses of air of different temperatures, the atmospheric pressure, the wind, and so on. We will study throughout this unit how to understand this kind of. This is a meteorological satellite that allow us to study the atmosphere. And this is a meteorological station that have the different elements that allow us to know the different elements of this atmosphere. This is an anemometer that studies the wind speed, a rain collector to measure the amount of rain, this plate that studies the solar power. Well, it doesn't study solar power, sorry, it simply collects the solar power for making electricity for all the station to work. This measures the wind direction, is a weather vane, and this is a sensor of temperature, so a thermometer. Here we can see a meteorological station which is larger for more complex studies, for example, for measure the solar radiation. This is a climate graph. You have already studied and create one climate graph in your exercise, and you know that it has some bars in blue that represent the precipitation, so rain, and a line in red that represent temperature. Remember, in red, this line is temperature, and in blue, these bars are rain, precipitations. Precipitations and temperature are the most important things we should know in order to understand climate and weather, because they are the two main of the atmosphere. Every time we are talking about the atmosphere, we have to mention both and precipitation because they are the elements of climate. Temperature is the degrees the air have. When we're talking about temperature, we're always talking about the temperature of the air, and precipitation is the rain the water that falls from the sky. It can be rain, snow, hail, etc. There are other elements of the climate that we will study, which are the atmospheric pressure, the force of the air over our heads, the wind, which is the movement of the air, and humidity, which is the amount of water vapor we can find in the atmosphere. The world has different temperatures in the different areas of the world. They can change throughout the seasons and throughout the times of the year, but in general they have a regular distribution. The hotter temperatures are closer to the equator, while the colder temperatures are closer to the poles. And in between, there are the temperature areas, the ones that have a temperature condition. They are warm, they aren't very hot, and they aren't very cold either. This is due to the solar radiation, so the amount of energy we receive from the sun. Remember that in the equator, the sun hits the earth vertically, so the rays hit the earth in a vertical way, which allows them to give much more energy to the to this center. So this area will be hotter, while this area receives the solar rays more indirectly. It doesn't receive them directly, vertically. So they can't warm this area as much as this. For that reason, this area has a hot climate, while these northern and southern areas have a cold climate. And in the middle, we've got a temperature one. Remember that this is due to the atmosphere, which is a very thick layer of gases. So when the sun hits the earth, it had to pass through this layer. Here it hits directly. I'll put it in red. It hits it hits it directly. It has to pass through this amount of gases, which is not so much. But for hitting them here, it has to cross all of this amount of gases. It's much more. So it have to crosses a long distance. So it loses energy. It can't well, hit the earth so directly. And also there are more possibilities for the rays to be reflected and so on. So we can distinguish different zones, which is the hot zone in the middle, the cold zone in the poles, and the temperate zone in between. We know this, but it's important for us. This is a map of the insolation, so the amount of sun area received, and that creates climate zones. When studying the climates of the world, we will distinguish the different climate that can be created throughout this. You know, the at the north and south, those polar zones, which are very cold. In the middle, the tropical zone, which is hot, and in between them, the temperate zone at the north and at the south. So temperature. It's an energy source. It's the main energy source of all the atmosphere. Remember that because of the sun, we can have wind. The wind is moved by the energy of the sun. We will talk about that later. We have the atmospheric pressure. We also have the rain. Why? Because without the temperature, the water wouldn't evaporate, so we wouldn't have clouds, so it wouldn't rain. Those main processes take place thanks to the temperature. It has different effects on our lives and our world, beneficial effects. That means that they can affect us in a positive way. It's good, it's needed for our health. We need to receive the light of the sun. It provides us with vitamin D, which is good for our bones. And it's also beneficial for domestic, industrial, and agricultural uses, for example, as an energy source, or for example, for the plants to grow. You can't have agriculture without sun. And for economy, think of the bars that have tables outside for the clients to sit in the times of good temperature, or simply the tourism that goes to the beaches and to goes to the shore in summer. And of course, it has also harmful effects. These harmful effects are due to the excess of sun. It can create skin and eye diseases, and it can have consequences for flora and fauna. An excess of temperature or excess of solar radiation can be harmful for us and also for other living beings. The Earth's heat is transmitted to the atmosphere. Uh, that's the thing that causes temperature. Remember, it's not that the sun heats the atmosphere, but the sun hits the earth, and the earth can transmit that heat to the atmosphere, to the air. It's an indirect process. Now we have to talk about precipitations. Of course, we all know what rain is, but we need to be able to define it properly. Rain is, of course, the water that falls from the atmosphere. This is due to the water vapor we can find in the atmosphere that condenses, created clouds, and due to the lower temperatures, these clouds get colder, the water vapor condenses even more, create these droplets, small drops, that for its own weight fall to the earth. If they cool down quickly, instead of becoming water, they can freeze and create snowflakes. So small uh, ice crystals that join together and fall to the earth in the shape of snow. If they cool down even quicker, they create balls of ice that fall to the earth in the shape of hail. And for different processes, we can find other aspects. For example, the frog, which are these small droplets, these small, uh, well, the small masses of water, very small drops of the size of millimeters or fractions of millimeters that are suspended on the earth because they are very, very light, and they simply cover the landscape. Rain can have different causes. We will study this more extensively in Unit 5, but we can say that rain always takes place because the air goes up, the water vapor on the earth goes up as well, and when we are higher, we are colder. Think of the top of a mountain. The top of a mountain is always colder than the bottom. So when the air goes up, the water vapor cools down, it condensates, and it rains. That's the main explanation. For example, it rains or it snows a lot on the top of the mountains because of the condensation of the water vapor then. It can be from a mountain or it can be because of different masses of air that join. Again, we will explain them later, but when a warm mass of air and a cold mass of air meet, the hot air goes up and the water vapor, which is with this hot air, with this warm air, which is explained here, goes up as well. So the clouds get colder, they condense, and it rains. Or it can be simply because of the heat from the sun. The air gets hotter and hotter goes up. Because the hotter goes up, the clouds condense and it rains as always. So precipitation. Then we need to know what our humidity is, which is as simple as the water vapor in the air, the amount of vapor which is in the air. It's measured with a hygrometer. The hygrometer can measure the amount of water in our earth. It is measured in a percentage. We can say that we've got a 10 percentage of humidity, 20% of humidity, or even a 100% of humidity. That means that the air can't tolerate more water on it. And if there are 100%, is very easy for it to rain because the air cannot support more water. Vapor condenses and forms clouds with droplets, so small drops, or ice crystals when they freeze, and they precipitate in the shape of snow, hail, or rain, uh, fog, and so on. So rain, hail, frost, which is the small layer of ice that cover everything because of the freezing of the water vapor, the dew, which are small drops of water that condenses over the surface of the cold things, especially in the morning, and the fog, which are these very small drops suspended on the air, and snow, which is when it falls in the shape of ice crystals. Precipitations are essential for life. Uh, we need water to survive, as simple as that, and it also modifies the landscape. Why? Remember when we were talking about erosion. Erosion can be caused by water, and this water comes from this precipitation. They fall and they can erode a mountain, for example, for creating a valley between them. So then we can talk about atmospheric pressure. Atmospheric pressure is the weight of the air over our heads. The air has a weight. It's heavier or lighter depending on its condition. We are used to that. We don't notice that we have air over our heads, but we've got kilometers of air over us. In the same way, we can notice the pressure when we are going underwater because we are used to the pressure of the water. The pressure of the earth is there and affects our world in different ways. And it's measured in these kind of maps, which are called atmospheric maps. We will study them There are different elements that affect on this atmospheric pressure that can be the air currents, such as the jet stream, which are currents of air that flows constantly, always in the same direction and always in the same area. Jet stream affects north of Europe and is responsible for precipitations, for example, that cover the Great Britain because it passes through it and the north of France. Now we need to be aware of one very simple fact that we already know it, but we need to remember, which is that hot air is lighter, so it rises. As simple as that. The hot air goes up. It goes always up. And this is very, very, very important to understand how the atmosphere. Why? Because the hot air, as we have mentioned, goes up. And it goes up creating a lower pressure. That's very, very important. An area of low pressures. Because as it is ascending, it doesn't have force our heads, our over our heads. But then, when it descends, it creates a much higher force over our heads, and that creates a high pressure. Okay, why is that? Because of the temperature. Hot air goes up, so hot air creates low pressures. Cold air goes down, so cold air creates high pressures. That's extremely important. They also go down or up in this shape, creating spirals like this. The anticyclones move on the in clockwise direction, while these low pressure areas move in counterclockwise direction. So this moves like a clock. This moves in the opposite direction. It's very important. We need to know low pressures is when the air goes up due to the heat. It's hotter, so it goes up. High pressure is when the air is colder, so it goes down. And it has lots of why? Because what happened when the earth went up? When the earth went up, it takes with it the clouds. So the clouds get colder and it precipitates. It's extremely important for us to know this. So in the areas with low pressures, we will have air that goes up and it precipitates. In areas with high pressure, the air goes down and it doesn't precipitate. Let's see this in a climate map. Here we've got numbers that mark the pressure. The pressure is marked by these lines, which are the isobars. The isobars measure the atmospheric pressure, and we can uh, notice the most important areas because they have A's and B's. And A will always mean high pressure. Always mean high pressure. What does high pressure mean? That the air is going down in like the movement of a clock. The B will mean the opposite, low pressure, and it means that it goes up in the opposite sense that a clock. When the air goes up, it creates clouds. Why? Because the water vapor goes up and condenses. And when there are clouds, it can rain. So this area, which have a low pressure, will be a rainy area. You can see that it covers the British Isles. So England, Ireland, and so on, which are very, very, very rainy areas. While what happened when we've got high pressure, that the air goes down. So the water vapor doesn't rise, doesn't cool down, so it doesn't create cloud. It creates sunny and dry days. Where is it? In Spain and Italy, which are normally sunny and dry areas. Here we can also know where the wind is. The wind, I'll draw it in red as well. The wind always go in between these lines. Wind is flowing like this. The closer the lines, the more important difference of precipitation of atmospheric pressure we will have. So the stronger the wind will be. And also, we know that the different masses of air move differently according to the pressure. High pressure moves like a clock, clockwise. So, in this direction. On the other way, uh, uh, an area of low pressure moves in the opposite direction, opposite to the clock. So, like this. What does it mean? That, for example, for Spain, is taking the air from here and taking it to the Iberian Peninsula. Here we have Africa. This area, which is closer to the equator, is a hot area. So, if we've got a hot area, the air will be hotter as well. For that reason, here we've got a hot and sunny day. While here we've got the wind coming from the north, which is colder, and also from the sea, so it will be humid, and that means that in that area we will have a rainy day, rainy and a bit colder day. This led us to these shapes. These red circles and blue triangles show the masses of air. These are a hot mass of air. These are cold masses of air. We don't need to worry too much about that, but we can see, for example, we said that the movement of the air will push this hot air all the way back to Spain. Here, which is in purple, is because we have a hot and a cold masses of air colliding. They are mixing. That's all that we need to know about an atmosphere map. And uh, we should need them because we will do an activity about that. These are everything we should know about the atmospheric pressure. Atmospheric pressure depends on altitude, air temperature, and air currents. Altitude because on the top of a mountain the atmospheric pressure is lower because there's less air for us. So if we got a very tall mountain and this will be the atmosphere here, we've got less air in top of our heads than here. So here there will be more atmospheric pressure in this point than in this point at the top of the mountain. Depends on the air temperature because remember that hot air goes up, and depends on the air current that can also affect that. It's important for the erosion. Remember that the wind can erode mountains and so on. The dispersion of the seeds of the plants that are moved by the wind, and for the wind farms, the ones with the aerogenerators that moves thanks to the wind. And we can distinguish two very important elements: the depressions, which are the areas of low pressure because of the hot air rises like this, and causes low pressure because it doesn't exert a force over our hand, and causes precipitation because the water vapor goes up, it condenses, and it rains. On the other hand, we've got the anticyclones. The anticyclones are when the earth goes down, the cold air goes down, it descends, and it causes high pressure and dry weather because the the water on the air doesn't create clouds because it's hotter. It doesn't get cold, so it doesn't condensate. So cold air that goes down and creates dry weather. Very important. Hot air that goes up causes precipitations. That's everything we should know about atmospheric pressure. Then, the wind. The wind is a consequence of atmospheric pressure because, as we have already said, it blows from high pressure to low pressure. As the pressure is pushing the air, it has to move the masses of air to other areas of low pressure where there is a place for the air to go. As simple as that. That will be the diagram. The wind is represented normally or traditionally as a god, Iolus, and knew that there were some constant winds that blow at some specific times of the year. People in the countryside knows this very well because it's important for knowing when a storm can appear, which area of a mountain is more or less windy, and so on. Those are the continuous wind that affect. Also, there are some other constant wind. For example, the Canary Island has the trade wind called alisios that always blow in this direction, as we can see. To know the direction of the wind, we can use a weather vane like this. That it spins, letting us to know where the wind is blowing, in which direction. We can also know the speed of the wind due to this anemometer. That spins due to the wind, letting us to calculate its strength. So the wind it moves from high pressure areas to low pressure areas. There are some prevailing winds that are constant, such as the alisios or trade winds. There are some seasonal winds that depends on the seasons. They blow to some at some specific moments of the year, such as the monsoon, which is very important in tropical areas because it takes the rain, and local wind that can change depending on the situation of the atmosphere. They aren't constant. It can be measured by an anemometer that measures the speed of the wind, and a weather vane that measures the direction. That was everything we should know about our Unit 4. So thank you very much for watching. And please, if you have any doubt, don't hesitate to write me an email to the direction you know, which is dot Jaime Arias Jimenez at gmail.com. You will be supposed to do some activities based on this presentation. These three, I'll put them as well in a Word document for you to complete if you want. And you will do also a very brief test. I'll put this test on your Google Drive file. Remember, your Google Drive file will be the our main mean of communication. These activities, as well as the test, are due for Monday the 13th. So the 30th, sorry, the next month, on the 13th of March, of course. So please do them. And if you have any question, any doubt, anything you need to clarify, please ask me. Do not wait for handing me the activities, for sending me an email asking me the question. Please send me your question as soon as you detect them. Uh, you can watch this presentation as many times as you want. On, of course, on the book is everything you have to know. Thank you very much, and please ask me any question you can have.